where I was. Right. So I was explaining that maybe I will again share my screen. So you can see my screen.
No, right now we are not seeing. Kindly share
Okay.
again.
Okay. Now you can see my screen again. So if we are designing or maybe detailing or designing any kind of steel bridge, the main important thing about these connections, that how we want to consider, and also in bridges very important thing, generally initial engineer do not know about the bearings. That bearing plays a very important role in design of any kind of bridge, because the bearing is the one thing that will connect your superstructure to the substructure and foundation. If we do not consider the bearing effect and its rotations and its moments and its direction forces free, or maybe what kind of bearing we required in the initial stages, we have to decide it. Generally, if we do not decide the bearing correctly, after designing the superstructure, we generally happen lot of problem in designing of substructure and foundation. It is, I'm telling as per my experience or as per anyone experience, before even the initial design we try to fix the bearing, because bearing is the most important thing that will transfer any kind of force which will going to act on this kind of superstructure or any kind of like this. So you will have a lot of things should be considered at the in the preliminary stage. If you have already preliminary stage has gone through, then again you have to check the bearing orientation and its directions and all, that every force should be transferred from the superstructure to its substructure, like pier cap, pedestal, then pier cap to pier, then pier to foundation. We have different kind of foundation available, if you know that we have pile cap, open foundation, well cap. Generally, well was used only in the you can say that if the bridge is 100, more than 100-meter length, or the span connection only the span is 100 meter, then we generally try to use the well foundation, or otherwise we ignore it because it is very difficult to construct at the site. But only rivers or you can say that sea we require the well. Otherwise pile and open foundation generally have been adopted in every place. Pile is the most common one, but if you have very hard rock beneath the soil, so we will go to the open foundation. It is depend on the soil also. Soil interaction is also important, and if you so let me see one soil interaction example where will be utility proportion. Just give me 1 minute. This is not. This is. I think so. Soil interaction means we have to consider the accurate soil properties according to the soil parameter, like what is unconfined compressive sand, what is angle of friction, what kind of soil is there, it is loosely packed alluvial soil or some kind of sand or hard rock or igneous rock, weathered rock. That kind of condition we have to consider in the modeling of pile itself. Like I will show you. Like if you look at here, this is box gutter bridge. So we have model pile and pile gap, and this pile have been modeled according to the soil, and spring stiffness have been provided according to the soil parameter, which is deflect the your true behavior of piles in the at the time of loading, or at the time of this calamity like earthquake or you can say that wind forces, temperature forces. We have to check these pile according to the every kind of different situation and all we have to check. But the modeling should be done very accurately, because it will play a significant role in the initial stages. Previous engineer, when the this software capability is not available, we generally can able to do this in the excels also, but it will not take the accurate behavior. We do not know how to take the behavior of soil in the excel in previously, which is very difficult. We can able to do, but not like that's the whole pile group we can able to do. Only one two we can able to check. But due to the software advancement. Now we can able to design and construct the whole bridge in one go. Like I can design the everything in one model, but generally we avoid it. What we do, we if you require less amount of time, two engineer works parallelly. One will take the superstructure, another will take the substructure, foundation, and everything. So the superstructure will give you the reaction forces only. You can directly apply reaction forces onto the top of like this is not the model. Uh, that one model. If this model have been completed, you can take the forces from the bearing and directly apply it on the substructure and foundation on the pier cap, and you can design it accordingly. That's why bearing is important. It going to separate your superstructure from the substructure and foundation. So these kind of things are also very important, and the soil is very important. Generally, we avoid the soil if you are doing the preliminary design. But still, if you are doing the anyone doing the preliminary, they have to consider that it will going to your give you number of pile or foundation size, pier size, or anything you require for the detailed design. But at that, if you work any DPR projects or any kind of preliminary design project, engineers generally avoid it because we do not have soil data. It required a different team, geotech team. You will require to get all the parameter and all, and you required another consultant to do the your survey work and soil work. So that's why consultant in India generally avoid it. Even the you can say the international market right now avoid in initial phases. But at the time of detailed design, you need accurate all the thing. You can assume something as per IS 2911 if you have work anyone. So 2911 will give you uh, parameter about the piles and capacities about the piles calculation and everything, that how much horizontal deflection we should consider, how much other things should be considered at the time designing of piles and pile gap. Pile gap is fine. Pile gap you can design. There are two different theories have been available. You can design it as a beam or as a truss. So that is a different thing. Pier is same as if you design pier as per IS code. So as per this bridge code is the same. Nothing you will change. Only some parameter will be changed, and you will need only to consider the bidirectional forces, the horizontal force, the vertical the force, and the horizontal shear force, and the moments, longitudinal and the transverse moment accordingly. The pier gap can be different, or this is spearhead. Generally, small one is pier called known as spearhead. This also have different theories for the design. You can design it as a cantilever or the corbel, or it depends on the size, A by D ratios. The superstructure generally it will be as per your span arrangement, or sometimes client ask you some special literature like client will tell you I need steel girders or I need concrete, then we have to move according to the client. Generally in superstructure it depends on the span and the client requirement. If you have a span around 25-meter, you can easily go deck slab culverts, you can go RCC girder, and you can also go PSC girder, which have very less amount of sizes, or you can able to save lot of concrete and steel in PSC girder, but cost will increase due to the pre-stressing and pre-cast material and all. But that is also good because you do not need to cast it on the site. Do not need to put all the bracing and the supporting material for the casting of this box girder if you have the PSC girder, pre-cast PSC girder. And if you have cast in PCSC girder, that is will be the different thing. But up to 25 meters, generally we try to use it RCC girder, which is easy to make and easy to maintain and easy to, you can say that, rehabilitate. Like if something will happen, we can directly provide the another layer. We can chip out the layer and we can provide another layer and again put the concrete, then our bridge will work fine. But in these kind of bridges it is very difficult to rehabilitate. Even the steel bridges, if you have this kind of, so one part change required lot of very difficult to change, because every part is connected and every load is be transferred to every part. So if you want to change any part, you require the temporary support or the temporary part maybe at the bottom, then you can able to change something. or maybe some accident happened. If you seen right now, a lot of bridge accident happen even in India and outside of India. So for that, we need to again check and calculate everything according to the original drawings and detailing, that how can we able to change that part, or it is possible or not, or we have to deconstruct the whole bridge or again construct it. That should be done by structural engineer also. And you have
So, like
yes,
after this, making this superstructure, we will
yes.
go for the substructure. And this
Generally,
you
what
are, yes, you are
I
doing
will
in the, yeah, Midas. After
Hmm.
that, the
It
strat
depends. I
for,
have STAD
yes,
also, CSI Bridge also. Midas generally give you 3D view look. It will look like good in Midas, and also Midas is good for the PCSC design, which is acceptable all international market. But STAD cannot able to give you the PCSC design. CSI Bridge can give you, but CSI Bridge is a little bit more complex. So generally people are adopting Midas right now.
okay,
In India, no, very few consultants have been using CSI Bridge, and even the international market, some old people are been using the CSI Bridge, but the new generation have been using Midas right now.
Midas. And also, like in this program, we have the stat also. Okay.
Yes, we have STAD also.
Stat
It is for
also, yes,
yes, for the steel bridge grillage analysis. For the analysis purpose, I think the best software available right now is the STAD, which is very user friendly and it can take very less amount of time. Midas is a little bit more complex. CSI bridge is the most complex one. If you do the detailing and the applying load, everything in the Midas, you cannot able to easily change parameter after completing the model. But instead, we can easily able to change, and also we can share the. There is also instead there is a STAD editor in which we can work like a coder, or you can say that coding we can do directly
yes.
and apply everything. But in Midas it is difficult. We have some coding work in this MCT command shell, but it will not going to change that much. If you need new things should be added, then it can be used, but you cannot able to change the old things which you have already defined here. You have like if you define dead load and everything. Now if you, so this is the SIDL load have been applied, so you cannot directly able to change. You have to change it by maybe delete it or by remove it. That can, but this can be done easily in the STAD, and this is same for the CSI bridge also. So, but Midas is good because of the two things. First of all, it will give 3D look. Another thing is the PSC result. Like if this you have this box girder, and if you do the PSC of this box girder, so whatever the stresses or the result we get, these are all approved and have been checked by the senior structural engineer, or maybe you can say that the top faculty of every consultant. So they have given the approval that we can able to use Midas for our projects. So that's why we generally model, or otherwise if you do this kind of girder in your Excel, or if you want to create your Excel, it will take a lot of time, maybe 1 to 3 months. It will take, it is according to your experience or how much you are capable in Excel, it depends. But in Midas we can able to do it 1 to 3 days, or even the two
Yes.
days it will take hardly takes
But
on the
for
preliminary design, only
yeah,
preliminary.
but for foundation design, like you use the Excel sheets, right? And there,
Yes, for the foundation generally we do not use any software because no, we use X software, it is known as AdSeg OSS, or maybe one another software is there,
can you
ASBD.
show can you show that one also?
AdSeg I don't have, I have
That
ASBD.
ASBD or that
I
Excel
will show
sheets.
you.
So
I
that we
will show
can.
you. I will show you. Wait a moment. Superstructure is there. Let me just show you what will we do. Mm-hmm. Where is that station? Not in this. Neom. Okay.
So, Ms. Meghna,
Mm-hmm.
you are understanding all the points that we are. What will be the things in the training program?
Yes, sir. Yes, sir.
This is like we are explaining through some examples. There is lots of things that we need to explore.
One
Okay?
moment.
Yes,
Now,
sir.
yeah. Hmm.
Sir, actually, will I be,
Hmm.
able to learn complete design procedure?
Yes, from the initial to the
Complete, like considering all, if one bridge has to be constructed, like what are the loads that we have to consider,
no, we
considering
will
all
tell you.
those
I will
loads,
tell you everything. Like,
designs, everything. Yeah.
you have loads.
Detailed design.
Detailed design. Totally. I will understand. I
Yes,
will
sir.
show you one culvert detail report, something like this.
Sir.
If you have, what will happen? That's how we will create the report.
Yes, yes.
You have everything should be defined in Excel, but only analysis part should be done in the Midas or any kind of software which will be available. This is a box culvert, or you can say that underpass. So we have to define everything here, that how much pressure we have to apply, how much water
Uh,
forces, collision force, live load. Then we have to apply it in the Midas, everything the same. And we generally, what we do in RCC design, we do not do in any software. For that, we have different Excel available. This is as per ASHTO. We have different for the as per Indian codes and as per Euro code. It depends what code or what environment have been required. So as per this, I can show you the drawings also.
so that means these design sheets you are making us to prepare by ourselves, or like
Yes, so
you are
generally
giving
what
the ready design sheet.
no. What will happen? I will tell you. Some
Uh,
previous person have been work on this Excel, but again, what will happen? We have to again check it, or maybe code have been updated. Like right now, I am creating for the steel. What is steel arch bridge Excel, so which is not available. Sometime Excel is available, but again you have to check it that Excel is accurate. Now this Excel have been available previously. Now again I have to check it and verify it with the code. I have to update some parameter which is not updated because it was done as per the previous code. We have all the clause have been, we have to define it, every clause and everything, that from where we are considering every calculation and everything, and how parameter have been considered. Like if you know that, and as per Indian, we consider FC, but ASHTO and Eurocode does it FC dash, which is known as cylindrical strength. But Indian code use it cubical strength. So steel strength is always same, and you have then E is always same. Elastic modulus sometime different, but it is also same. The under square root of under root into the same thing. The what will have, but in this, yeah, this is known as cylindrical strength. Then you have some parameter. But again, if you are using anything or designing, we have to check everything by the code itself, or by back calculate, or we cannot directly able to use, because if you are using this Excel, what we'll do, I will change something and I will forward it to any engineer. It is his responsibility or her responsibility to check it before using it for their project.
no, sir.
So
Actually, my question is, you people are giving us the design sheets,
yes, I
so
can
no
give you.
need. It is no need for us to prepare it again.
Yes, you do not need to
Because
prepare.
it takes lot of time, no, sir. That's why I'm
This is
asking.
not Excel can
Yeah.
be created in a one day. It will take a lot
Ah,
of experience and years to create.
yes.
Even you required someone higher authority to check it, because what will happen if I create any Excel, I cannot able to approve that Excel. I need a director
Okay.
level approval for submission to the client, or submission to anyone before going
Okay.
forward. That kind of things have always been required. So this Excel have been approved like this. We can directly, because it is approved by client also, our internal team, external teams,
Mm-hmm.
everyone have been able. We can use now new Excel which I have been creating. That is required a lot of approval. That kind of thing. So it depends on your how which and also your experience. If you are good with the Excel, generally it is. And if I show you, this is one drawing. And if you see reinforcement and everything have been considered, like this is you can say that GAD dimensioning and everything. Then you have slab dimensioning, so different section, then reinforcement, other drawings which have been connected. It is all like developed by me, or I have draftsman and vendor working me, so that they have developed according to my directions and everything. But you will have different kind of this bridges. This is for the outside of India. In India, culvert is you not do not consider in the bridge, but outside they consider everything in the bridge. Then what will happen in steel design? We can directly able to design in the Midas itself or the stat, but they have still have different checks also, like local buckling, global buckling checks according to the different code. Then you have the different and also if you have PSC design, you do not need to design it Excel the superstructure. Only ULS check you have to do it in the Excel. SLS check can be easily accommodated as per the Midas result, and also like deflection checks we can directly do as per Midas result. Only the RCC component, which is the software give you the conservative side. What will they will do? They will consider everything on the conservative side. For that thing, we required the special software. What these softwares are generally only for the section designs, or some like this. If you have bidirectional movement, like peer, if you require the advanced Excel or you require the advanced software. So two things should be available. I have worked on the both of them, but generally I prefer the advanced software ASBD or the AdSec, which give you more advanced result due to their use of non-linearity of material. This is known as what is analysis? Non-linear analysis, because you have concrete also and steel also. So you do not have the throughout concrete or throughout steel. So non-linear analysis will be required for design of these kind of thing, like pile and pile gap. A pile gap can be done very easily, very easy design. It can be done by anyone or which have basic knowledge. The main thing is generally come only how to how to look into the forces, and what you cannot able to design directly pile cap if even if I can give you model right now, because it depends on how you consider the. Have you designed previously anyone pile cap, that how
Yes,
forces?
so
Hmm? Have you
piles
designed?
for
No,
DPR purposes. Yeah.
no, I'm talking about the pile cap, how pile cap can be designed, just the basic theory, just how you will get the moments in the pile cap. Generally, by software it is not possible. We do it by manual calculation. That's what I'm asking. You need pile forces, then we have to calculate the pile cap moments for the design. So do you know anything about that in the DPR? Even maybe if you work in the DPR, have anyone little bit give you any exposure about how pile cap have been designed?
Like through bending theory. We used to
Sure, fine. I'm not
Yeah.
talking about the bending theory, but how
Yeah.
can you get the bending moments in pile cap?
Yeah, at the reactions from the peer.
No, not from the reaction from the peer. From the reaction from the peer, they will directly going to pile cap, and then pile cap going to supply the reaction into the piles. You
Yeah.
need reaction from the piles for the design of pile cap, not from the peer. So if
Okay.
someone have not worked any kind of design of pile cap, they cannot able to answer this, because you do not need reaction from the pile, this peer. You need
Okay.
reaction from the pile for the design of pile cap. So that is the main. It depends on which kind of theory. If you have trust-based theory, you only need forces from the. But if you are using bending theory, generally bending theory have been used because it is more economical and it saves a lot of steel. Trust-based theory have been used 5 years back, but right now no one is using, because it takes a lot of steel, and your client or contractor do not want to put lot of, because the steel is right now too much cost. It is getting costlier and costlier day by day. So everyone want to avoid. And also we bridges also
Excuse me, sir.
depends. Yes.
Actually, India will not use the pile,
Hmm.
the spring pile. This is the first time I'm looking this
What
spring piles. Spring piles, spring piles. What is a spring
models?
piles?
Model spring pine model.
Yes, yes, yes.
Okay. So you have not
Yes,
working. Where you working right now? Like in which state you are right now?
yes, India.
No, India, in which
India, oh,
state?
UP.
UP, and which
Yes,
UP
yes.
Noida?
No, actually Lucknow.
Lucknow. I think you have not
Yes.
worked with which consultant maybe, because
No.
according to I have working a lot, working with lot of consultant. I have known about Jacob, WSP, Aisha, even Lucknow Metro have right now design.
Yes,
My
yes, yes.
colleagues have been designing right now. My friends have been working for. Even I was not at that team, but about Mumbai Metro, I have designed. Delhi Metro, I
Yes.
have designed. And I have designed lot of ROBs for the Maharashtra region. I have designed for the international project lot of bridge, but everyone have to consider this pile as a spring model. This is the basic
Yes, yes,
need you need to consider for good consultant. If you have that, what I'm telling, if you have very old mentality people, then they generally avoid it because they want to do it according to what they have learned initially. They want to consider that kind of thing. But right now, if you know about anything in ACOM, Sestra, any consultant right now have been doing same, and I have worked in those consultant. So no issues. This is the correct way we have to do it. Otherwise, you will not able to get the pile deflection. Why? I will tell you. If you do it by manual calculation or in software, you will consider this point as a rigid, or maybe make it as a full contact with the soil, or you will provide support, fixed support here, or maybe on the
yes, yes.
pile fixed support. What will happen at the time of earthquake? In the soil, this is not fixed. You have compressibility of soil or rock or everything is available. Due to that, you will not get the accurate behavior. This is not on the concrete, it is on the soil. So soil have some compressive you can say that properties, and also some water content will be there, and air will be there. Due to that, these piles are not wholly fully contact with the soil. Even if with the fully contact, they can easily able to deflect in this direction or in this direction. This is run model. And if I show you,
So all the candidates are getting Mr. Jay's point, like
this is
he
the
has lots of experience in this design. You can
yes.
ask the question regarding this one. And also with the different software, but right now he's explaining through the MyDAS.
You can see piles are also have been deflecting due to wind force. Now wind is colliding from this direction and taking the superstructure. Your pier is moving. Due to that, little bit deflection is occurring on the head of pile. So we have to check this deflection also at the time of generally it should be checked at the preliminary design. But if some client will require, then we have to give this as per 2911. Its limits have been given D by 100. You can able to see. So that should be limited. That we should not be more than that. Otherwise, we have to increase number of piles, or maybe we have to change the orientation of pile gap. Something we have to do, or maybe we have to increase that load. That kind of things. Does it have anything? Not. This is generally for EQ. Not the okay. This is different one. And this is continuous bridge. So continuous bridge will have different behavior. You can only see in continuous bridge in the special environment or something. You want to save little bit thing, breaking maybe. Yes, you can see lot of deflection on this pile. Like look like this. If you look at this is the main thing, because the central pier is generally continuous one, so it will take the huge kind of uh, deflection. And also before even starting any kind of modeling, you just have to do the modeling and check your model further going that my model is accurate. uh, Generally what will happen, we try to do the modeling and put the all the load and everything. We do not check our model geometry and its connection with the substructure foundation, and afterward we see, oh, our results are wrong. So we have to again do it modeling and everything, repeat the process. So it also takes lot of time. So this is the braking force. Like if vehicle is moving and it apply brakes, so that kind of behavior will going to happen a little bit different. This is a CB all maybe. No. So that kind of behavior bridge will going to. This is happened due to that bearing is free at this end and also at this end, and it is a pin here, like only going to take the not the pin, like vertical reaction. So bearing are also important, that they are allowing the superstructure moving in the longitudinal direction. So your substructure and foundation remain in contact with the soil and everything. That's why the bearing is the most important one. Otherwise, what will happen due to that, this moment, this pier will going to move in horizontal direction and maybe going to break, or pile will going to fail. So in continuous bridges, you can see I have increased the number of pile here, 10 piles, and other groups have been 8 piles. So this is the thing generally come with the experience, and also this kind of thing maybe you have not worked with the computers and all. So in every project we model like a spring stiffness. If you do not consider spring stiffness, it will give you result, but it is more of on conservative side. And if some proof checker or any third party will check, it will tell you that you have provided higher sizes, higher reinforcement, but that is fine. But right now we avoid it. We do not want to overrun the cost or overburden cost on the contractor or the client. Like government, if in future something will happen and government will ask your design and ask you that how much how you have designed it and how you consider forces, how you done analysis, so they will question yourself or your company or authority that how you cannot able to design it by future software, and how you design it by old techniques and all. So generally that is also one thing happening, because at the time of starting my career I have seen everyone design it as a fixed support or pin support. That is maybe I have worked only 1 year. After that, everyone have been working like this. But if you want to design in only in the Excel, like I can design this whole bridge in the Excel. If I want to design by manually or Excel, then I cannot able to consider this as spring stiffness and everything. I have to assume it everything is fixed and rigid, which will more conservative. Like you will get 20% higher result or forces or steel. That kind of thing is happen in every kind of bridge, not in this bridge. This is a continuous bridge. This is the most complex one, which will give you very high forces. But as per other forces, it is we do not want to consider anything. We always consider this. If you have well cap, that is a different thing. Open foundation is also very crucial one at the time of, maybe if you consider the soil properties, then you will get the safe bearing capacities very accurately. Otherwise, you will get some assume safe bearing capacity for the open foundations. Open foundation, nothing, pile will be removed and this pile cap will become your open foundation. Any other question you have?
So, hello.
Yes.
Yeah, we have Mr. Hasmi. He's from Sri Lanka. So, Mr. Hasmi, have you any question regarding any doubt in your mind?
Uh, so far,
Mhm.
nothing. Like I
Okay.
just want to know, like for the reinforcement modeling, what software will you be using?
Reinforcement modeling generally, I think Aman will explain. Aman, can you
Yeah.
explain?
So, see, this is one part that we are going, Mr. Jay, he is explaining about you, like how you can, like, what you can say that
We can
design
able
and
to
analyze.
calculate. Yes, we
Yes.
can calculate in reinforcement.
Yeah.
But the
After calculating this reinforcement, okay, we will do this all the things in the Tekla structure. There is another software that we will use for the like finalization of the detailing sheets. There all the drawings we will abstract from there. Okay, I will show you some of the files from there. And after design and analysis, we will move to the detailing. Okay, so in detailing part, first we will learn different type of software. Like we have the RAM connection, and also the STAT is there. So you will also able to learn the STAT Pro. So STAT Pro and RAM connection that will give you expertise in the steel part. Okay, so the steel part for that one. So in initial stage, first we learn the analysis and design. Then we will move to the detailing. Okay. In detailing and advanced modeling, there is one concept that is called the advanced modeling. Uh, I think that you may aware about the computational design and their like parameters like grasshopper. They are widely used in this bridge industry or bridge design consulting firm. They are generally hiring people based on the computational design and drafting and detailing. Okay, so the Tekla and Grasshopper that are very different part. but we will abstract the information. After design and analysis, we will get into the Tekla structure, RAM connections. We have different type of software that we will utilize. Okay, Hasmi?
Okay.
And
Do
also,
you like,
yes, please.
excuse me, like, do you like go to the AdSec? Do you know about this software,
Yes,
AdSec?
I know about the AdSec OSS.
Yeah. Because
Is it the
after
OSS brand of software and AdSec? It's it is used for only you can say that non-linear analysis of the steel or concrete structure. Generally, we do it only after design of modeling of this in the midas. What we'll do
Yes.
in AdSec, we design the piers or piles or this pile gap or pier gap, but or maybe some checks of superstructure also if required, like transverse analysis and the design of transverse reinforcement. What we do the most complex part in the AdSec OSS, like pier design. It is very difficult to design it manually, so we take the forces from the midas, then we design it into the AdSec. And maybe I have one file or not. I will show you maybe some results of AdSec. Let me see it. Where is, and also there is another software for the international market, ASBD, Autodesk Structural Bridge Engineer software, bridge design software, which is also same as AdSec, and it is also, but AdSec have one major drawback. It do not consider the torsion at the time of design, but ASBD can also able to take the torsion. So both software have only this one different, but AdSec is majorly easily available and its license fees are also very less as compared to other software. And right now in India, I think every consultant have been using AdSec for the design of pier and piles. Generally, it is always used for the bidirectional bending moments and this vertical forces. You can say that P. So
So, like this is for the analysis and design part. We will have different like module in the program.
and,
So, any question having from Mr. Jain, like regarding the codes, which code you will use, Mr. Jain?
a
Like
code we can use Indian code and ASHTO code. We have
ASCII
even,
code.
yes, ASHTO code generally have. Hmm? Hello.
Okay. Yes. Yes.
ASHTO code
So,
have been accepted in this. You can say that
okay.
in the whole Middle East right now. Every and also some African part also. And we can also use Eurocode. Generally, what will happen? Some clause we have to take it from the Eurocode and some from the ASHTO code. Some clause have been available in ASHTO very good, like design of corbel, nibs, and some steel design of steel structure design code have been good for the Euro code. So we take some clauses from the Euro. We combine it. It is not like that we generally go from one code, because if you required in the time of detailed design, we required everything should be checked from every code. We do not want to at the time of future, we do not want to say that you have not considered this clause and this clause and this clause. So we generally take all the clause. But if you can also consider one code and directly give them that we have considered one code, and code does not support it. But if your client or proof checker asks you to refer different code, then you have to do it. It is not
Okay.
like that you can only use one code.
Okay. Fine.
Even in
So,
India right now, in the design of metro and you can say the railway bridges, we have to refer from the ASHTO code or Euro code also. It's same. You do not need to consider any other thing. You can directly refer.
fine. So, like from today's session, I think all of you have get the idea like how we are dealing with the things. Okay. Any question anyone having, you can ask.
Mhm.
Hello. Ma'am, your voice is
Mega, I think your voice is
there is
breaking.
some background noise is coming. Hello. Your voice is not clear, Miss Meghna.
1 second.
And you, Mr. Hasmi, and
Hello,
yes, ma'am. Now.
sir, can you hear me now?
Yes, yes, now it's okay.
Sir, here we are dealing with metro viaducts and railway bridges as well, or only it is limited to
No,
highway?
I can tell you railway viaduct and if you want to
Okay.
know about that, metro bridges.
Okay.
That is fine.
Almost all type of bridges are there. Okay.
Okay,
It's
sir.
not that much different. A little bit difference
Only
about the
loading, sir.
loading have been different, and
Ah.
little bit about the behavior. Railway bridges
Okay.
have continuous loading of due to railway, so some extra loading will come into play. That is only the thing. Other load will remain same, like dead load, seismic load, and you can say that temperature load. That will remain same due to because structure is same, but only behavior change due to the this continuous loading of railways and the discontinuous loading of the highway. One thing in this or not? Nothing have been shown. Okay. So you know about this also SP16. Generally, you if you want to design manually, you can able to design it by SP16. If you do not want to use ADSEC and ASBD, then you have to design piers and pile as per. Have you worked, Meghna, on this SP16 for the DPR project?
No, sir. Like
Okay.
in buildings, we used to use this one for
No,
columns, I guess.
no. In building, SP16 has been used only for the detailing purpose, not for the design.
Because this chart I'm familiar. I don't remember exactly.
These charts can be used for any pier or any kind of thing,
Ah,
but it is generally used in the bridges because in building you can directly design by IS 456 and provide the detailing as per IS 13920. You do not need to refer from this graph, and you can directly design as in the STAD itself or the E tabs directly. I think that is more accurate and save you a lot of time. But bridges cannot be designed in one software or in one go. Bridges have different component and different working parts. Building have different things and different geometry have been involved. Bridge little bit. If you learn little bit about the bridge, you will say bridges are more easy to design as compared to building because the modeling part is very easy and forces getting the
Their
forces is also
criteria. Yes, their
Forces is
criteria are
also easy.
fixed.
Only bridges have the component have been on. You can say that very huge. You at the drawing you cannot imagine it. It is 100 200 times generally the scale. So that is a thing. Only the thing is a scale. If you remove the scale word or scale thing, the bridges are more easy to design and easy to consider. But if you do not have any complex project, if you have something very complex, then it will take you a lot of time. Even take you 6 months for design of one bridge only. But only you can also design in 1 week one bridge also. So that is up to the bridge geometry and everything and how capable you are. Like if you are very comfortable with the loading and behavior, so it depends on yourself also and your interests. If you do not like it, designing or maybe in the initial phase civil a little bit, you have to read codes, you have to read books. Generally, people do not want to do again like after completing education. They do not want to read and write and everything. They want to just do the job, but you need lot of reading and writing. Even after experiencing of 20 30 years, people are still used to read codes and read books, read papers, international papers, journals, because they required for the but if your basic is clear, that will be good. But you required a lot of learning after that. If you design any kind of, if you want to make career in the bridge, you have to prepare for the learning itself, like self learning, not from anyone. Like if you I will tell you this is from the ashto code. Generally what will happen, maybe you have to go through the ashto and look at the clause, or if this is from the code, which code have been used. Is code have been a lot of type. You have different code for the concrete bridge have been different code, steel bridge different code. Then you have different code for the metro rail structure and railway loading, railway structure. Your calculation little bit change. Then you have different code for the building itself, like IS 456 for the bridge, IRC code. For the railway loading, we have IRS code. We have lot of different codes. That will take your time, a lot of time. And what will happen, some little things will change only, but the analysis will remain the same. Only on design part little bit things will have been changed.
Okay. So, like, hope all of you have get the point. Like, and for our upcoming schedule, I will send you all of you the detailed schedule about the program and topic wise or weekly wise that sheet, okay, the schedule. So you will able to find that at on which day what will be happening. And generally in 1 week we have 3 to 4 sessions combining the design and analysis and that other part. Okay, this program are like very vast. If you see their content, like explaining the content, it will take 3 to 4 hours. Okay, in full manner. So today we have taken this analysis and design. In next class we will take different part. Okay, I will send you the systematic arrangement, okay, for the series, and then we will begin with the training. Okay. So this all about today. Hope all of you have enjoyed the session, right? So anyone
Any
having any
have
question?
any doubts they can ask,
Yes, if you have any doubt, you can ask. Okay.
or they want to specify any specific thing.
Yes,
Yeah.
so like I want to know, like normally in my project also we use MyDAS for the
Yes.
for modeling, but there is another one I quite recently heard of called Sophistic.
Yes, Sophistic has also been used, but for the Sophistics, you will not get any that kind of thing. Crack software.
Sophistic
If
is
you need,
soft.
if you
Yeah,
want to
sophistic are
learn, you cannot able to easily find the Sophistic crack. And
that is
also,
very like costly also.
yes, that is the
Oh,
thing. Sophistic have been used. It is same as Midas, only a little bit more advanced than Midas. Right now, for the special projects, Sophistics have been used. Some consultant are adopting, but what will happen? They are taking both the licensing. They do little every project in the Midas. If some special project like cable stay bridges also good in the Sophistic, some kind of special bridges. These and also if for the Nordic regions, Sophistic have been adopted very regularly right now.
Yeah,
Only
also
for the
that is,
Nordic.
yeah, that is very compatible with the grasshopper and computational
Yes,
design.
for
Okay.
the BIM
yes,
purposes.
yes.
Yeah.
So for
So
the parametric modeling, isn't it?
yeah, parametric
Parametric model.
modeling.
Totally got it. Even
So
that Midas is going right now for the conversion of parametric modeling. I have seen it, but
uh-huh.
Sophistics is good software. I totally agree with you. It is better than Midas.
Oh, okay. So like if we learn the MyDAS, like
Mhm.
if we have become
But
like
if
advanced through this course, we can also apply the same thing in Sophistic and
yes,
we learn,
Sophistics
right?
also. If you learn the Midas, generally it will not take hardly maybe 2-3 days for the Sophistic, because all things are same. Only some in Sophistic there are a lot of you can say the coding is there.
Hmm.
In Midas there is no coding. In the STAD also there some coding is there if you require. Then if you are very comfortable with Python and all, then Sophistic is the best one. But if you're not comfortable with
That
the
is,
coding type of
yeah,
stuff, then the Midas is a good one.
that is civil
Because
influenced by the IT industry. Okay.
that is fine. I know about that.
Sorry,
Sophistic.
I didn't get.
Okay,
Uh,
fine.
IT, the civil engineer have been
okay, okay.
influenced by the IT engineers.
IT
Yes.
engineer. So you need to see there is lots of programming language. Basically, in the grasshopper, like in one module, we have some of the basic part of the grasshopper. You will be able to learn that one also. Okay. So that, but we need to start from one module, because if you start with a different module at a time, it will create problem. So first we need to clear the design and analysis, and then after that we will get into the advanced modeling. That is the parametric mode. Okay,
Okay.
and the detailing and their other part like steel detailing. We have some of the other software like RAM connection. So widely we will use that one to detail, and we will complete the structure. Okay, we will complete one full project. Either it's any kind of project, we will complete with full pledge of the process. Okay, so you will see that how the company is working and how they are delivering the project. Okay. You might have working with the company, so this is known to you. Okay. So thank you again. Today, like tomorrow or day after tomorrow, our classes will get started. Got it?
Any
So
other question you can ask anyone.
okay, okay, fine.
So like when we modeling the bridge,
Mhm.
like say segmental bridge,
Yes.
like we have say like normally this one which you have this now, you
Mhm.
have model it is a maybe 85 meter plus 860 meter, that
Yes.
bridge.
Mhm.
Between two moment joint, we is the one how we do in my dash. Or we, if the bridge is more than like 5 kilometers, say the bridge is a
Yes.
continuous bridge.
Okay. Okay.
In that case also we have to do like that, or we break the bridge into different between the moment
Yes.
joint and we do it.
Yes. Now what will happen here? This is a continuous bridge. If your bearing have been apart from its like this, from this to this is what will happen. We have to define it span according to its support. Like this to this is one span, but due to the continuity of this whole thing, this will become one span with continuous support, continuous span with one support. If this bridge is also continuous in another direction, like in this direction, you have continuous span with two support. So that thing is different. But other thing, yeah, like if you have 5 kilometer, if I give you example of metro viaducts, metro viaduct does not have any continuous you can say that superstructure or viaduct. What they will do, they will break it into one by one part. You have two bearing in this side, two bearing in this side, then two here, then two here. In this kind of bridges, I have two here, but only two here. I do not have a four type of bearing is here. If I will show you maybe properties, where is boundary, support, elastic link. You can see here is my two bearings. Here are only two bearing. If I provide this four bearing and divide the superstructure from the mid, then it will become the single span simply supported structure. It depends on the how support condition we have provided, and I can able to take it more continuous, or I can able to break it here and provide it like a this simply supported. Continuous structure have been used which we required less cable, less amount of size of superstructure, and you can say they can able to construct in one go. And you have little bit more complex, because the cable should be passed from the top of a structure, bottom structure. But it is good for the reduction of concrete and the steel and the size of the whole superstructure. If I design this bridge as a simply supported, the superstructure size little bit increase, and also my cable and my forces will going to increase. If you
Cable
know about
mean
the uh,
right, tendons. Cable
hmm.
mean, you mean tendons?
Yes, tendons.
Okay.
Tendon will reduce here in the continuous bridge, because I do not require any cable and this part here. Only I require the top cable. If you know about the bending moments, we have to provide according cable according to the bending moment itself.
Hmm.
Show you a little bit. So you have this kind of bending moment. So you cable is always move like a bending moment also. So I do not require any cable. This cable will move here from here to top, then again bottom, then again. And what I will do, I can able to do the pre-stressing in one go. If I have a 50 meter and 50 meter span, or maybe 80, 60, I can save lot of money in pre-stressing by doing pre-stressing of continuous bridge in one go. But if I
Hmm.
have simply supported bridge, then I have to do this pre-stressing differently and this pre-stressing differently. This is also major advantage of continuous bridge and the simply supported. But continuous bridge have a little bit more concerning about the secondary effect or secondary forces, which will come due to the pre-stressing, due to the dead load, and that will increase or save increase forces, or for the long term effect increases. So that is a special literature we have to consider at the time of continuous bridges, because we cannot able to provide a higher stressing. Due to higher stressing, this bridge will try to put the forces on this pier, and they will try to put the forces on pile. This force will increase on the substructure foundation due to pre-stressing itself. So we have to design very carefully continuous bridge. But in the simply supported bridge, even if we provide more conservative cable, only the superstructure will be effective. No substructure or foundation will be effective. That it depend. That what I'm telling in the bridge design and the environment and how contractor is requiring the bridge. That is the main thing we have to consider. Sometimes we design it as a simply supported bridge, but client will ask you, no, it's increasing the cost. Maybe you should consider. Sometimes we do not have any option, like span is very high, like if I have 60 meter span and this 40 meter, I want to design it not as a simply supported, I want to design it as a this continuous bridge. So throughout one section I can be used, only number of cable I can able to change or reduce. So it depends totally a lot of factor, how forces, how the span, how traffic is going between these two, how we can able to provide the support for the this at the time of casting of concrete and everything. Because if we are this if this is a segmental, this is fine. If it casted in one go, like up to here I want to cast it, then up to here I want to cast it, then up to in three parts, that is a different thing. Casting stages also have been chosen by generally contractor because they have equipment available already in their inventory, so they try to do it according to their inventory also.
Mm.
So these things should be
Most
considered.
of
But
most of the time nowadays we go for the precast,
because
and we
precast
erect.
have been used very good for the simply supported. What will happen in precast, directly you have the superstructure and you
Mm.
can take it from the casting yard and put it here by the cranes, and nothing, you will save a lot of time also. Because how can you can able to save time at the time of precasting, you can able to cast pile cap, pier cap, and also simultaneously your superstructure have been casting at the casting yard. uh, After completing this you can say that pedestal, we can take the this superstructure from the casting yard, and its maturity have been attained because of maybe 30-60 days have been required for this casting. So this thing also required minimum 30 days. So after 30 days you can directly able to put it, and it will save you a lot of time. And also you do not require any um, staging to put the concrete, and you do not need to block this area for the putting the superstructure onto this. That is one major advantage of precast. So precast have also, this is in Midas we can able to do the construction stage analysis. So that is the very good at the time of these kind of thing, precast, cast in situ, or maybe segmental. So that is very advanced thing which is available in the Midas and Sophistic. Only these two software provide these kind of advantage in the construction stage analysis. Other software generally does not have that kind of much do that kind of complex work in very easy manner. We have some other, but generally not us. You can say that if some company comfortable with the Midas, they want other consultant also, because they want to proof check also. Engineer go from one company to another company, so they do not want to move softwares easily. That's the thing. So Sophistic, that's why it is not comfortable right now in many, because already people have been adopted the Midas, but they are moving to Sophistics right now only for the special bridges only, nothing for the common bridges right now. So any other thing like so the continuous and the discontinuous. If you have 5 kilometer and they simply supported, what will we do? We will only analyze one span which have the same, like if I have only 30 meter of span, so I will try to analyze 30 meter span. And also one major thing, I have to check the soil properties. Like my soil properties varies after 100 meter or 200 meter, then I have to update the pile spring accordingly, or then I have to analyze again. If my soil properties and pile capacity is not affecting that much, then I do not have to create other models. I can directly able to design one simply supported span, and able to give this and also the height of the superstructure and bridge also affect, this pile length also affect, these thing affect the for the different kind of modeling. But you do not need to model the whole 5 kilometer bridge in one go,
Mm.
because
It's
if you
always
model it,
better to
yes,
divide, break it in
yes,
between the movement joint and do.
yes, it is simply supported. You can say that simply
Yeah,
supported moment joint.
simply so.
If you break it, it will become simply supported, or if it become continuous. It depends on yourself, or also or your geometry and everything. The constraint have been used, but we try to avoid the continuous, because sometime what will happen, we get the secondary forces very higher. You have tendon losses very higher side, so we try to avoid that. And also the manual checks of this continuous bridge is very difficult. So manual checks of the pre-stressing can be done, but it is generally the special literature have been required, as special code have been required. But as per Midas, if you are doing nothing, you need only you know about that by little bit manual check, your results should be accurate. That is the thing. If your results are not accurate, then again you have to do the modeling, and again you have to change everything, the parameter and all. Maybe we have done something wrong or something not working right.
If you are using the launching girder for this particular erection, then we have
Yes.
to put the erection
Construction,
load also.
yes, construction live loads. Yes.
Okay.
Yes, that is known as a construction live load if you are putting this erection by a segmental launcher or any kind of launcher have been used. Generally, launcher always come onto this pier cap, so they take the all loading of launcher. Other the superstructure will not take any effect. If superstructure will take, we also take the load also, because sometime what will happen in the, if you know about the balance cantilever bridges, in balance cantilever bridges, the cantilever bridge itself take the launcher effect or
Yes.
assembly, launching assembly.
Hmm.
So that
But it's more of in situ, right?
yes,
Casting is
not in situ. Only cantilever are only used for more than 60-meter bridges or 50-meter. One moment.
Okay.
Yes. Any other
So,
question you have?
okay, fine.
okay.
So today we will end this session, and I will send you soon the schedule of the program and each and everything. Okay. So thank you very much for to join this session. Okay. Again, we will meet tomorrow or day after tomorrow. Thank you.
Okay. Thank you. Thank you.
Thank you.
Thank you.